Hello, everybody. I think we are live. And welcome to this third session of the Civo DevOps Bootcamp. My name is Kai. I'm here with Alistair. Say hi, Alistair.
Hi, yeah, nice to see you all again. You'll get sick of my face by the end of these sessions, so.
Yeah, Alistair is our absolute all-star helpful ambassador who's running point on a lot of these. So yeah, this is the third session of our bootcamp. The first one was on an introduction to DevOps. The second one last week was about containers and containerization. And today we are going to talk about building and testing. So the sort of continuous integration part of the DevOps lifecycle. So what we're going to do is start with a quick sort of overview discussion and then move on to a demo. And that is Burrito the cat behind me. So if she moves or jumps onto the onto my desk, I'm going to have to mute momentarily. But yeah, so yeah, let's just jump straight into it. If you have any questions, please ask them in the YouTube chat. We are watching that. We hope that we are going to cover a lot of things that you might have questions about, but if we don't, shout and we will get to them. So yeah, should we get started?
Yeah,
excellent.
Great. So yeah, kick straight off.
Yeah. So I think the first thing we kind of need to talk about is where do testing and building fit in the concept of DevOps? And if you attended the first session, you remember that DevOps is it's a culture. It's not like a strict this is what you do things, but the intention is that you have a culture that feeds to itself to ensure the continuous delivery of value and good stuff for whatever it is that you're building. So
yeah, and that kind of feeds into this continuous improvement, continuous feedback lifecycle stuff. So the two bits we're going to be talking about today are build and test here. And then I think through the rest of the sessions going forward, we're actually going to move around through the rest of this cycle and kind of come back on itself. So build and test are important, but they're not everything. You know, if you automate all your build and your test, you're not instantly doing DevOps. You're just kind of, you know, it's a good indicator that you're moving in the right direction, but, you know, doesn't mean that you're doing all of these great other things in this continuous feedback loop.
Yeah, and the other thing
test.
No, go ahead.
Because test doesn't just mean code as well. You can bring this test factor into like the whole life cycle, the whole continuous loop here. Because you can build your tests into your plan code phase. You can say, right, we want to test a hypothesis about what might increase customer traffic or conversion rates. And you can have tests that sit outside the kind of testing my code bits as well. So testing doesn't have to just be about code.
Yeah, exactly. And that's kind of it's not just in the one place where it says test at the bottom of that diagram. It's about like, you know, it's about getting a holistic understanding of what it is that your product, not just your code, but your entire product does. So, you know, and that, like, as you said, Alistair, like it's not just necessarily that your code that you're testing. You can also have tests for things like known vulnerabilities. So if you, like, everybody uses libraries and things that they get from other people and sort of integrate into their own code, and obviously those have their own attack surfaces, so that there's obviously it's important to stay on top of knowing what the status of those things is.
Absolutely. A couple of questions in there about why I'm standing. I've got a standing desk. Everyone was right.
Yeah. And then I think we're going to go into this next. There's a question in the chat about the difference between continuous integration and continuous delivery. So CI versus CD, and you quite often you see them put together as CI/CD. I mean, do you have a concise, snappy definition of what the difference is?
Yeah, I think continuous integration is about getting your changes merged into a deployable state frequently and continuously. So I've worked in some places where you'd have your main code branch, which might be called release or something, or production. And then people would branch off to make code changes and then spend 3 or 4 or 5 weeks on this separate branch before trying to integrate their code changes back into the main production deployment branch. So the idea between sort of continuous integration is you're doing this all the time. And an extreme version of this would be every commit. You'd make a branch, you'd commit, and that commit should be able to then be merged straight back into the branch. And if you've got lots of automation and automatic tests and all of these things, you can kind of do that continuous integration piece without a lot of work and effort and things. So kind of the continuous delivery side of it would be every time you merge into your production branch, your main branch, or your master branch, whatever you want to call it, that will go straight into production. It might go through a series of like quality check gates, like I think we'll discuss this later, integration tests or performance tests or anything, but it's about when you integrate your code into the main branch, into the main deployable branch, it getting into production environment and being delivered. So there's a kind of they're similar but different. Very, very few people and places do true continuous delivery, in my opinion, which is as soon as you commit into the main branch, it automatically goes straight into the production environment, possibly automatically through different environments, but very few places do that. It can be a scary concept to think about, right? You've made some changes and you merge your pull request or have you do it, and then it's suddenly just that is going to make its way to production without any human interaction.
Yeah, and like boom, there's your new version available to download or to view or to use, whatever. And it's literally done by the virtue that you've done git commit, pressed enter, git push, and it runs through its thing, and your new deliverable is out there. And yeah, I think that's a really good way to distinguish the two, is that continuous integration is the code side and integrating your code. And then there's the delivery side, which is what comes out of that code.
So there's a question that's just popped into my eye that I can see from the chat that is, do we write tests in the CI stage? You can actually write tests in both stages. So your continuous integration type test would be your unit tests and your integration tests. But then for your continuous delivery stage, you might be doing like full system tests or conformance tests or performance tests. And then if they pass, they're kind of a bigger system level test. If they pass, you can promote your code for other environments. Sometimes you can test in production, which I'll probably discuss later on because I'm an advocate for it. It's amazing. Cool. So if we move on, do you want to intro this?
Yeah. So when we talk about testing, what do we mean? And generally, what we're talking about here is automated testing. So the things that you can run, and you have specific test assertions, test scenarios, and you get a positive or a negative result. And there's different types of tests, obviously, and Alistair's probably going to run through, like, he just mentioned that you've got unit tests and integration tests, and there's a bunch of different ones. But the idea with all of these is that it gives you confidence, right? So if you ask this question of, if I add this feature or if I change this code, how do we know that the product still works and does what it needs to do? So you're building effectively a confidence scaffold. You're putting things to prove that whatever it is that you're writing works. And there's different, this is why you're not just writing them necessarily in the CI stage. You could be writing them, all the way in the sort of planning stage. You could be writing what are known as conformance or acceptance tests. So a user coming in and using this product will be able to do this thing, right? And you can keep that in mind as you're writing your other tests, so that by the end of your feature that you've written, that test will happen and it will pass.
There's also a good thing to highlight here with the different types of testing. They do different things, and they're to give us confidence in different areas. So things like unit tests, we're testing like a function or a method level, they should be really quick. They should test, I've written a function to add two numbers together. I'm going to write tests that all it does is it calls this function directly, adds two numbers together, and checks that I haven't somehow managed to times them together or take them away from each other. And then as you move up so we've got like unit tests, we've got integration tests, which might test more of I will spin up my entire service and call an API and see that I get the right overall result out, which might test 4, 5, 6, 7 different functions. But the higher up the layers you go, integrate a unit, integration, end-to-end, conformance, they tend to get slower and slower. So we tend to have, I think, is it called like a test pyramid? Like a pyramid of
testing, yeah.
Pyramid of testing. So you have your unit tests at the bottom, you have loads of those, and they run really, really, really quickly. And then as you move up, you have fewer and fewer tests. So that as you go through the stages of continuous integration and continuous delivery, the developer still has, or whoever's making the change still has that ability to get really fast feedback. So if I break my adding function, I don't want to have to wait 2 days to run all the conformance tests in the entire universe to work out that I broke adding two numbers together, which is a single function, which I could have tested in a split second with unit tests. So we want to sort of stack our tests towards that pyramid. So right at the top, you might have like a couple of conformance tests or acceptance tests, but you might have hundreds or thousands of unit tests. But your unit test should run really quickly, so you can get that fast feedback. We had a question, I think, about running tests on your branch.
Yeah, exactly. So you would be running the tests. The kind of do you execute unit tests in a local branch? And the answer to that is yes. And so when you're developing, when you're doing your feature, when you're writing your code and your tests, you will be executing the tests that are relevant to that particular thing, on whatever schedule you want. So you can even have it every time you save the file, it runs your tests. But those same tests will be executed as part of your sort of continuous integration pipeline, which we will talk about next, every single time that you push the code. So basically, you're just like Alistair was saying, you layer tests on top of tests. So in order for you to actually deploy a new version of your product, of your app, you will execute all the tests. But if you're just developing on your local branch, you don't necessarily need to execute all the tests, just your unit tests or your sort of immediate integration tests.
There may be other reasons as well as to why you can't run your integration tests or your high level. You might just not have enough power on your laptop or your desktop to run the full test suite, or you might have some really annoying third-party dependencies, databases, or third-party APIs that you just can't access locally. So you might then run those in a integration environment or inside your pipelines, which we might talk about in a minute. So there's loads of reasons, but basically you should be running the fast tests as frequently as possible. And as the tests get slower and slower, you run them like later and later in the pipeline. So you should have pretty good confidence by the time you get to your like conformance or end user tests that your change is going to at least work and run in your environment.
There was another question that got highlighted on the screen earlier, which was about whether chaos engineering or chaos testing is part of this. And like my first instinct that it's not the same as your unit or your end-to-end testing, but it's sort of part of the later stages. So if we go back to the sort of DevOps diagram, Alistair, if you can go back a couple of slides,
Wrong way.
Yeah. So when you're sort of operating and monitoring, chaos engineering would be sort of part in there, because you're not necessarily introducing, and we might do a session on chaos engineering later. I don't want to talk about it too much because it's not really relevant to today. But chaos testing is about resilience rather than proving that your code works.
Yeah, that's a good point as well. And this is kind of the testing in production that I mentioned a little earlier on. I'm a big advocate for running platform level tests all the time in as many environments as you can. So let's say you've got like a development environment that all the engineers code, like microservice environment or something. You can run synthetic load. You can build code that exercises tests continuously in that environment. So rather than having to like log on and do some stuff, you've just constantly got these tests running essentially in production. I mean, I've worked places where they were running tests like this in production with a fake user or a test user that they created, and they were constantly running big suites of tests all the time, essentially testing in production. But obviously all those tests have been running in the other environments and other things have been tested. It's just, you can know before your customer knows that there's an issue on the platform, and you can proactively log in to fix it rather than waiting, terrible thing of one of your customers emailing you at 4:00 in the afternoon and going, "Oh, is your application broken? I haven't been able to log in since 2:00. So trying to avoid that and kind of running these chaos engineering as well as these are sort of acceptance and conformance tests in the thing. I've been asked to mention that the registration link for the bootcamp is in the YouTube description, and there's a webinar on the Civo channel
tonight, sort of in a couple of hours after this one, which is about Glue Edge. It's going to feature Sayan Pathak and people from Glue, and they are going to talk about managing API and Kubernetes. So it's a little bit sort of deeper than this particular sort of session. But if you're at all interested in Kubernetes, attend it. Ask all your questions. I'll be there. I'll be attending. So. We'll be taking your questions there. But yeah, so what you were, just to go back to what you were saying, Alistair, is this is about building confidence, isn't it? It's about, writing good tests gives you immediate feedback if something is no longer working before that customer calls you and says, hey, hold on, I haven't been able to log in for 2 hours. Why is that?
Yeah, and I think this is an interesting point as well. Like throughout this bootcamp, you'll notice we're very light on the tools actually telling you how to be DevOps and the actually writing these tests and coding, because DevOps is far more about the philosophy and the mentality behind it, which is why we're really heavy on this discussion information thing. This is like, this is what I feel DevOps is. It's more about knowing why and how and when to implement these kind of things, rather than, oh, I've implemented unit tests and integration tests. Aren't I great? Aren't I DevOps? So that's
there was
one thing.
There was that question earlier about like, what are some of the disadvantages to automated testing? And, it absolutely isn't the be all end all. Like writing automated testing, you can absolutely miss vulnerabilities, because you can find some edge cases. You can prove that your code works in this case and handles an error gracefully in this case. But sometimes you honestly don't know what a user or a combination of APIs working together is going to cause, right? And that's,
absolutely.
That's one of those things you can't.
You don't get the kind of exploratory, oh, what if I put 10,000 characters into this input box? I used to be a manual tester back in the day, and that would be one of my like go-to things. You'd get like a 20,000 character string and put it in an input field just to see if the developer's done it. I mean, as a developer, you can test for that, but a lot of the time, like you just forget, or you don't think about it, or you just go, oh, no user's going to do that. And those are the kind of things you can automate. But that kind of exploratory testing, what if I put it's there's a place for it, definitely. It doesn't, automated testing doesn't solve everything, but if you have a good automated test suite and you find either a customer or your manual testers find an issue, the first thing you should do is write the automated test which shows you exactly the error that they're seeing. So you then go back and fix your code based on a failing test. Yeah. So it's kind of the concept of test-driven development. Do you want to run quickly through it, Kai? Or?
Yeah, I was specifically, kind of going to say that, we're not going to so much talk about specific techniques or practices, but test-driven development is a really interesting paradigm, which is you you start with, as Alistair was saying, you start with a failing test. You write a thing that you want to happen, but you know doesn't. So to take this example that Alistair was saying is, if somebody puts more than 250 characters into this input field that is going to, it's going to give you a little beautiful pop-up saying, sorry, this is an email field, please use a shorter text, rather than save it to the database as attempting to be an email address. And that's not going to work because you haven't implemented it at all. And then you start sort of working toward a little bit, okay, can you detect the length of this string that's being passed? And you write a test for, we can test whether the string is longer than 255 characters. Okay, so now that passes. Then you go, the next test will be something like, we will not save anything to the database that is longer than 255 characters, and so on and so forth. And eventually you'll be, and Alistair was saying, you might have hundreds or even thousands of tests, because you will have these little micro tests that take a fraction of a second to execute every time you do them, but they give you that sort of idea of, okay, this is where, if you get a failing test, you will know exactly what was passed, what function caused it, and how you can fix it.
Yeah. There's an interesting question popped in about from Kunal. How can you understand a project by seeing the tests? And I say this, and I say sometimes I'd rather see an open source project which has got lots of tests. Like, if you could choose tests or documentation, which one would you choose? And there's no right or wrong answer to that. But personally, I would say tests, because first of all, you get the confidence that the code has been tested and it's going to do what you want to do. Whereas, and those tests will show you how to actually use the library or the code or whatever. It will say, right, if you call it with these types of parameters, this is what you'll get back. So test can be quite good for self-documenting as well. But I think we've probably veered slightly off course.
Yeah. So, but there's a question on the screen right now. Does testing an app happen in every part of the DevOps cycle? And in a way, I would say yes. Some of it won't be this kind of integration test, automated testing, but there will be some sort of feedback that you're getting, because this is about feedback, right? And whether it's about your feedback as a developer proving that something that you've written as a piece of code works, or it's feedback that you kind of get from a user saying, I don't think this is giving me the fields that I wish it would. So define what you mean by testing, and yes, it will be included in every part of the DevOps cycle. Right? Yeah. Should we move on? So let's talk about continuous integration pipelines. So we've talked about kind of writing your tests and writing your code. And then what happened, what are the tools that you can use to extend those tests and make sure that what you're delivering is compatible, secure, and sort of works with all the other bits of your application if you're using a microservices architecture. And there's loads of different tools for this, ranging from Jenkins to Travis CI to the GitLab CI/CD and Circle CI. There's loads of companies, and they all do all of it really well, just in slightly different ways.
And there's also, it's good to point out that there's no right or wrong answer on the CI pipeline you end up choosing. It really depends on budget, the features you're looking for, how well you want to integrate. So if you're using GitLab for your code, then GitLab pipelines, I think is what's called, GitLab pipelines. So yeah. GitLab pipelines might be the way to go, because it's already there, it's already available, it's got a really tight integration. So none of these are like better than any other in any way. Subjectively, they could all be the right choice for you. But one of the key points with like a CI pipeline is you want it to continuously integrate your code, which is exactly what it says. So these all they can be configured to run on every commit. You can run your full, even building your code is a form of test. So you want to be able to do things like, I want to, if you've got a compiled language, I want to build it. I want to build the artifact. I want to build my container, like we talked about last week. I want to run my tests, which we're talking about now. Like every commit, you want to be doing as much. And also the other types of tests, like scanning for vulnerabilities. You have static code analysis, so you check that you've not made any mistakes or there's not any insecure things you're passing around. All the way through to like scanning your final build artifact as well with code scanning for those.
Yeah, and there's really clever things that some of these tools have, like including things like detecting if you've committed actual like an API key for a service that you need to use, and they can clean that up. They can go like, whoa, this should not be here, because the moment you commit this, and if it's a public GitHub repo, for example, like that's that key available to the world, right? So there's very clever things that these pieces of software can be configured to do to save us brain power, but yeah,
we've had a good question come in, which I didn't foresee really. What is a pipeline? We've just jumped straight into like a CI pipeline.
I was just about to kind of talk about this. So if you watched the session last week about containers and sort of building your container using Docker, right? So what this pipeline does is it takes your code as you have it currently, and you can configure it to run any number of sort of tests. So if you want it to run your entire test suite or check your code for known vulnerabilities, any number of things. And then it will also go Docker Compose or whatever your containerization or your compilation system is. It will do that for you, given the options so say that that you're going to be running a Java application on a Linux machine. You can have that build a virtual machine for you and then feed it the code to compile your Java application for that particular machine, if that makes sense.
Yeah, it's like someone said it's like a set of automated processes that let you do stuff, basically. Build, deploy, everything, literally anything. Like the sky's the limit. There's a question come in like, can we use Jenkins for JavaScript? I mean, you can use any of these to do anything. They are just ways for you to build a set of automated steps to do something. The sky's the limit. I mean, Jenkins, infinitely configurable. You can do whatever you want. There's loads of plugins to do stuff for you. Whereas GitHub Pipelines is far more like locked down to like building and testing your code. I mean, there are ways to make it do all of that stuff for you, but it's like they've all got their different strengths and weaknesses, but they can all do all of it, because at the end of the day, they are just computers that you can run code on, instructions, and do whatever you want.
And we're obviously, to go back to the first session of this bootcamp, and you should absolutely, if you haven't followed along and signed up to the bootcamp, you absolutely should. The link is in the description. But to go back to how development and operations kind of used to be two separate spheres. This CI pipeline stuff, or configuring this stuff, is more in the traditional operations side of things. So configuring your continuous integration pipeline and these tools that you're using is specialist knowledge. And, some people choose to specialize in this stuff. Some people choose to specialize in building really cool JavaScript projects, right? You absolutely can do all of it, but you might not want to, right? So if configuring really cool and really effective test suites and sort of integrations with different tools is your jam, this would be the part of things to look into as a sort of in terms of projects or building stuff for your hobby stuff.
Absolutely. So next slide.
Yeah. So we kind of alluded to this of like what does CI, what do the pipelines do? And since we're talking about DevOps and modern software delivery, we're ultimately going to be talking about containerized applications. And containers, once again, watch last week's session if you haven't already, but they bundle everything that you need to run a kind of application. And the idea is that they are always the same. A container that you build with a particular version of your code and a particular configuration will always be the same exact container, which means that you can always reproduce an environment to get a particular result from a particular input. So there's this this sort of maybe like software development maxim of like, well, it works on my machine, and then this is what containers kind of allow us to do is, okay, fine, we'll ship your machine. We will make an environment that is exactly like your machine where this thing works and make it work for everybody,
Yeah, exactly. And also an interesting point, like most of these CI pipeline tools as well, they also are running containers, which are known to be exactly the same every time you run it. So not only is the code you build exactly the same, the code you're building it on is the same. So I've worked in environments where people would build on their own laptop and then deploy straight to production from their own laptop. So if you've got slightly different configuration or settings on your laptop to say me and Kai were doing it, if I built it and deployed it, and then Kai did it. I mean, I'm on Linux. Kai, you're on Mac, are you? Mac, yeah. Laptop. So we've already got to like a major difference there. I mean, most of the time you won't even notice. Like we can both browse the web and open our IDEs and stuff, but the underlying sort of machine is very different. And things like CI pipelines means that we know with confidence, again, that every time we build it, if we use the same code, the same commit from our version control system, and we run it through our pipeline without making any changes, we're going to get the same thing out on the other side. So if we run all our tests in our CI pipeline, we know that the thing comes out at the end of it, if they will pass, is going to work every time, every time.
Yeah. And then, to add a little bit more of not just the fact that, Alistair, you're using a Linux machine, it might be on an x86 architecture. I'm running a Mac that runs an ARM processor, which means that the sort of actual compilation, low-level code stuff is entirely different. So that means that, what we can do is if I build a container on my machine that runs on my machine, it won't be the same container that runs on your machine. But what CI allows us to do is if we know what our ultimate deployment environment is, so if we know that we are going to run our web application on a Linux machine that runs Kubernetes, and that Linux machine runs on x86 architecture, then we know that's what that final container should be. And every time that we build that container, it will work.
Yeah.
Yep.
Demo time. I saw some questions come in like, are we going to do anything practical and hands-on? I'm going to do some live coding right here in front of you, and it will go wrong, and I guarantee that.
Yeah, but this is why we have half an hour to try it and then get it right.
Right. Let me move things over, and let me move that out of the way. So why is it? Oh, right. I'm going to have to stop sharing and then share again because it's trying to be clever. Share screen. The entire screen. And no, I can't do that. That one. Okay.
I saw, and by the way, sorry, while you're pulling that up, very early on in the chat, I happened to see somebody ask, like, is there like a Slack group or something that people can join to discuss this? If you join civo.com, if you sign up today, you'll get an invite to the Slack community. We have a beginners channel there. We've got all kinds of different channels. So whatever you're interested in, and Alistair is one of our ambassadors. He's sort of around. All of us Civo staff will have a little Civo badge next to our names. We're all there. So come join the chat. Also tune into the webinar tonight. We have a Civo meetup. The link is in the description. Have you managed to,
Awesome.
to find it, Alistair?
Yeah, can we bring my screen on? As if like magic. There we go. So I've written...
Sorry, can I double check from the audience that people can see that? Is it the right size? Should it be larger?
I will make it larger because it probably... font size. Ooh. For some reason, I can't click the box which says font size.
Oh, is it on a different?
Yeah, it's not popped it up. Font. Ah, here we go. Font size. How big should we go? 30. Whoop. Is that better?
Okay.
So I'm a Go engineer. So I've written some Go code. Hopefully we can see that. So what I've done is I've written a function which adds two numbers together, and this is not the most efficient way to do it, and there's a reason. And then I've also made a function to multiply numbers, but also I've used my add function to do my multiplication. So this is like the least efficient code in the entire world, because for my adding, I'm literally, it's intentionally so. I'm just literally looping through the I'm going to add and adding one every time. So, you know, don't at me. My mouse has stopped working, which is really going to be helpful.
Oh no.
I can get another one. Bear with me.
Right. So while Alex is looking for another mouse, it doesn't matter that this happens to be Go code. This is a demonstration of you know, the functionality of building containers and running tests. You're right, Alistair. Nothing. Trying to remember your keyboard shortcuts. I know you said in the channel, now it's the time for magic, so... By the way, this is why people dread doing live demos. Thanks, Nuno. Yeah, break is sponsored by Civo. We're going to have to figure out what we're going to do if we can't get it the demo to work. So yes, Mikan asked in the channel, we can code in any language. Yes, these demos, this demo happens to be in Go, but the whole point of what Alistair was saying about DevOps not being particular sort of practices or rules is that you can literally use any programming language you want. Whatever gets the thing done in the best way for you is the best way to do it. There isn't an objective best, if that makes sense. Any joy, Alistair? Are you with us?
Are you with us? I think so.
Yeah, I can see a mouse. Yeah, I can see a mouse moving.
Yeah, I've got my mouse. I also lost sound, so you're coming out of the computer now. Apologies, live demo on a Linux machine. Yes, so hopefully you can all see and hear me. But yeah, we've got these two functions here. Add loops through, it's really inefficient, but multiply also uses add to add stuff up. So it's a bit of almost a fake scenario where these two functions depend on each other. And it just goes to kind of reiterate and highlight the importance of unit tests. So I've also written two tests where, you know, first one I'm just going to add 10 and 10 together. Not very fun, not very inspiring, but that's going to call our add function and just loop through and add 10. I've written one for multiply, which is going to times 10 by 10. So we should know that we're going to get 20 from this and 100 from this. So I'm going to run the test, and it's written in Golang or Go. And you can see here that run the tests. It took 0 seconds, so little that it didn't even really register to run my 0.002 seconds, right? So I could run these every time I saved the file if I wanted to. So what I was going to do was I was going to change my add function to be an off by 1 error, which the programmers among us will have done many, many, many times, where I'm going to actually stop adding 1 time before I should. And if we haven't got any automated tests, we would potentially build this and go, okay, that's fine. My add function works great. Not a problem. But because we've got these 2 sets of automated tests, when I run my test now, you can see that they both failed because I've changed a function that another function depends on. So you can't just really look at your code in sort of single function and go, right, I think this function works, it's all good. You also have to write these tests in such a way that you give yourself more confidence that you haven't broken a different part of the system by changing this one function. So, having a really extensive set of tests for the add function would then give me the confidence that I hadn't broken multiply somewhere else. So if I didn't test add because I was like, oh, it's easy just adding 2 numbers together, then we'd have had other issues in our system. But I just do n plus add. There we go, and fix it in a different way. Much more efficient, and now our multiplication works. But what I've also done here is I've set up this project to run my tests every time I commit to my version control system. So I'm using GitHub Actions here, and I've written an action, or a sort of the beginnings of a CI pipeline, where we're going to test in 2 different versions of the programming language I'm using, and on 3 different operating systems. So you can see here, like if I wanted to test this myself, to run these same tests myself, I'd have to have a Ubuntu machine running the latest version of Ubuntu, a Mac, I'd have to ask Kai to do it, and then I'd have to find someone who's also running Windows to do it. But with these CI pipelines and these CI systems, they can let you very quickly go, right, I want to run this set of tests, but I want to run it in 50 different ways or 100 different ways. So say you're building an open source project, open source CLI or something, you're going to want to test it against various operating systems, various different CPU architectures and stuff. So this, you basically read through it line by line. This is this step installs Go, which is the programming language I'm using, with the Go version from up here. And then we check out my code and we run Go test, which in Golang, this runs all the tests it can find recursively down through the project. So I'm going to add my change. I'm going to say fix add function and push that. So I'm going to have to stop sharing and then reshare. I don't know where that's gone now. Oh, I've got too many things. Share screen. Actions, allow. All right, and if we can bring that on, wonderful. We can see that my commit that I just made, my change, is already started to build in my CI pipeline environment. And if we look at this, we'll see all of those. Yeah, sure. Good enough, I think so. We can already see here that we've now got each of those environments using each of those programming languages. So we've spawned off 6 different jobs, and they're all running. So far, all of them are passing. But that's just so I mean, we can have a look at here where it didn't work. A commit I did earlier, and you can come in and you can see that I had an error where I wasn't adding 10 and 10 together. So this is a really kind of simple code example of how you can set up a pipeline to run on every single commit you make. I've committed directly into the default branch here, but if I'd committed out into a separate branch and raised a pull request, which we can actually do now, let me do that. in the background.
While you're setting that up, I'm just going to quickly mention the fact that when we talked about continuous delivery earlier, this is the kind of confidence that would give you. Because if you were to start to deliver a new version of your application with every commit, by having tests that prove that it works, will give you the ability to stop something that ends up failing those tests going into production. So by in the example of the failing test that Alistair posted, that wouldn't have built a new version if he had that set up, because it just wouldn't have passed. It would have notified, it would have sent an email to the person who's the named maintainer and the person who pushed that change, and saying, by the way, sorry, that didn't work. Can you fix that, please? And then this is how that feedback loop works, not just on your local machine, but also on the development side.
Yeah, and it gives your teammates confidence as well that you've written and you've added tests that change the things you've changed, and that you're not going to cause them issues down the line by breaking it and then going on holiday, basically. So I've raised a pull request here. So I've added a new line because it's the easiest way to get a new set of things. But imagine lots of code changes. You can see here that, so there's a question like, are these tests always written in YAML? No. This is using GitHub Actions, which uses a YAML file. Jenkins has got multiple ways you can build and configure these pipelines.
And these pipeline sort of configurations are separate from your actual programming or from your code tests, which are defined in whatever language specific test definitions. So in Go, you're probably using Go test, aren't you, Alistair?
Yeah.
And then on, say you're doing JavaScript, there's different testing frameworks, or, you can use, so your language will have a specific testing framework that you can use to write those unit and integration tests. And then this sort of pipeline stuff gets configured separately.
Yeah. And then, an interesting point here as well is, I don't know, some of you may have noticed that this has run 12 checks, even though the last time it ran 6. So what a lot of these tools will do is they'll run your tests on your branch, which contains just your code, and they'll also run it on an environment where they've merged your branch with the branch you've created the pull request for. So if there've been changes, so say Kai had made some changes as well since I started writing my code, it will essentially merge or integrate our two sets of changes together and run those as well. So we could have a scenario where 6 tests pass, which would be the ones from my branch, but then Kai's also made a change somewhere else, which means that my changes don't work with his. So I wouldn't then merge going, oh, everything's good, my little bit works. But actually, my bit doesn't work with something that someone else has already completed. They may have completed it in the time that I was making my changes. So that's where this idea of continuous integration comes from. We've integrated both our changes together and run the tests against that. And we now have confidence that commit, when we merge, it'll run another build, just because we've created a new commit in the default branch. And you'll see here, it's already kicked off another build, running all 6 again. And that build should have the same output that the pull request branch did on our pull request. It should be the same set of code. So that's what it's running. That's what I had there. We've got 10 minutes left. I mean, I can try and build a Docker container which has this, and then add the step to run the build after the test. Should we give that a go? And we can keep going with the questions as well.
Yeah, please. If you've got any questions, definitely ask them now, because you've got about 9 minutes to ask.
I will switch screens and hope.
Sorry, go ahead.
I was just going to say, hopefully I don't lose all audio and Bluetooth again. So. Okay, I'm going to bring my screen on. Awesome. Right, so I'm going to create, so last week we saw about Docker, building Docker images. So I'm going to make a Dockerfile. Okay. And then here I'm going to start with my from, which says which sort of base set of code, set of operating systems do I want to use to run my code. So Golang, probably 116. Let me just Google it. Yeah, so I've been working in software engineering a long time, and I Google stuff all the time. So there's no need to remember any of this stuff.
Especially since building a Docker image isn't something that you're going to be actually defining every day. Once you have this set up for your particular project, you're probably not going to be editing it too much.
Precisely. We may be updating these versions, but we're probably not going to change the build inside it. So this is basically saying pull someone else's image that's got Golang and Alpine, which is a Linux distribution, inside it, and I'm going to add my stuff on top of it and run that. So I'm going to do add main.go. So I'm copying in this single file here called main.go. I'm putting it into the container called main.go. And then command is going to be go run main.go. So I've no idea if this is going to work, as with most of the things I do in life. So I'm just going to build that, which might take a moment to pull down that. So I don't have a copy of this locally, so it's downloading it. And then what it's going to do is it's going to copy this file across into the container. And then when I run Docker run on this image that I've built, it should run this. It's built, and now if I do run, what do I call it? Test latest. Oh, 200. Looks like it worked. So I'd written in here as well. I'd written this is like the default entry point to a Go function, to a Go program, and I printed out what happens when we add 100 and 100, and we can see that that's going to build 200. So every time we run this, we should get 200.
There's a really good question that came in that was briefly on the screen of where does the build happen? Does it happen on GitHub itself or somewhere else in our private server?
So GitHub, if you're using github.com and you've not got a self-hosted runner, so this is a nuanced question. Generally, let's say what I just did, that will run on GitHub's infrastructure. So they are hosting, they call it a runner for me. I don't pay for it. There's a certain amount of minutes you get per month, and they'll build that. But you can also, I think with GitHub Actions, you can definitely do it with GitLab CI. You can host your own, you can use your own computers to host the runners so that it doesn't run and build on someone else's infrastructure. And all of the tools work in slightly different ways. So Jenkins is something you build, run, and install yourself, whereas GitHub Actions can be like a fully managed service where all you provide is your code and this file, and it will do it all for you. I mean, I don't have a Mac to build with or a Windows machine, so this gives me the ability to sort of expand out my testing and give me again more confidence that what I've built is gonna work elsewhere.
And the key thing here is that if you are building something that that runs effectively like it's a website that you're going to be running, or a web app that you're going to be running on is something that you configure yourself. You can set those operating system parameters to match what it's going to be running on. So, for example, if we've actually got a guide written by one of our other Civo ambassadors to installing Jenkins on a Civo virtual machine and running that. And that means that you're halfway to building your own release pipeline for your own applications without needing to use something like GitHub. But it all depends on what you actually want it to do, right? So if you are interested in having it build for every operating system, then you might want to use a service that provides all of those things. But if you just need it to run on Linux, just, run it in a virtual machine that runs Linux.
Yeah, I guess this all depends on what your preferences are. So personally, coming from the operations platform side, if we're going to run and install one of these ourselves, it's going to be me that's running it. So obviously I'm going to tell the business, oh, we should use one of these self-hosted services. They're great because I don't have to look after it. But I mean, it's down to everyone's preference at the end of the day, whether your company wants to use self-hosted or managed or whatever their sort of risk profile is to these sorts of things. But, like I said earlier, there's no right and wrong answers. There's a question, interesting. When do you run it, and when you run end-to-end tests in a pipeline, how do developers take ownership of the end-to-end tests? We'll probably cover that in a later session, because generally you're going to want to run your end-to-end tests in a real, something which will notify the developer on the team. So this idea of being on call. So in a DevOps kind of organization, teams that build the service run it in production. So they'll generally be like what's called an on-call rota, or an on-call schedule for that service. So you can build automation that runs the tests, and if the tests fail, they will call the engineer for that team and say, look, this test has failed, it's your service, go and fix it. Like the end-to-end test failed, it's your job to keep them working, and then they will go and look and fix them. So yeah, there's not this separation between ops that run all the end-to-end tests and go, oh, this is broken, I'll fix it. It's the engineers in the team are fully responsible.
Assuming that your sort of test suites, the tests that you have written are good, then you will be able to see where exactly that end-to-end test fails, which means that you can isolate down to, it's down to this change. It's down to this particular thing that we changed, still passes the individual integration test, possibly, right? But you can then narrow down and quickly find the sort of exact point where the code's gone wrong.
Cool. Well, we've come to the end, I think. We're pretty much there. I'm going to give it a plug again. Come to the Civo meetup later on.
Yep. It's
meetup.
It's in 1.5 hours. No, I can't do math. It's 5 p.m. BST. And and definitely, if you haven't yet, check out Civo Academy, which is at civo.com/academy. And sign up to the rest of the sessions of this DevOps Bootcamp, because we have a bunch more really cool sessions to come. Yeah. Thanks, everybody, for watching.